Okay. So good afternoon, guys. We were looking at the rainwater harvesting examples since the last two classes. So we also talked about some calculations. It's a very simple calculation. So the table is basically you need to understand the type of catchment and then the coefficients associated with it. Whenever you have a type of a catchment, it has to do with the materiality. In the sense, the roofs are basically tiles or corrugated metal sheets. So depending on the material, it will have a particular coefficient. Now, coefficient is also the efficiency at which the water runs off from the surface. That's why it's called the runoff coefficient. Similarly, you have ground surface coverings like concrete, brick pavements, untreated ground catchments, soil on the slope less than 10%, rocky natural catchments, then untreated ground catchments, which are soil on slopes less than 10%, and also rocky natural catchments. Now, what happens is basically treated and untreated. Sorry, there's a typo error there. Uh, Now, the thing is that you need to also understand that the rainwater harvesting calculation or the potential is equal to the rainfall multiplied by the area of the catchment and the runoff coefficient. Now, the rainfall is also depend on the climatic, the amount of precipitation in that particular region or the area. Then it is basically the other is the area of the catchment. Now, area of the catchment is going to be your terrace area or your roof area in terms of a pitched roof. And then is your runoff coefficient, which is depending on the type of the catchment. Like, for example, if it's a sloping roof with Bangalore tiles, then you are going to utilize 0.8 to 0.9 as the coefficient, any one of it. But if it's made up of corrugated metal sheets or your GI sheets, which are colored ones, then it's 0.7 to 0.9. Uh, if it's of concrete, like you have in terms of like ladi koba ladi, so it's like a concrete or a pavement, like a brick pavement, then those are the coefficients which are there. Okay, the amount of rainfall, one thing that you have to keep in mind during calculation is the units. Please understand that the units are same. It shouldn't happen that you are looking at meters, but the rainfall, you multiply it, you convert it into then your calculations will go completely haywire. Okay. Next, Swati, are you able to? Should I take? Okay, can you give me control, Swati? Then I can shift the slides for you, if that's okay with you. Hello, Swati, are you there? Swati, can you hear me?
Kimaya, what was the typo?
What is the?
The typo, you said there was an error on the page.
The untreated ground catchments and treated ground catchments.
Okay, the last one is treated.
Yes,
Got it.
yes, yes.
Thank you.
Uh, Sahil, you raised your
Uh,
hand. Any question you have?
y- yes, I had a question. So, when we talk about ground surface coverings or
Hmm.
say roof catchments,
Hmm.
so it also depends on the, for example, if we talk about brick pavement, so does it also depend on the quality of brick pavement that we are using, or
No,
it is
no.
irrespective?
It is actually it accounts for it, but the runoff coefficient will take care of it. That's why I said no. It's the efficiency at the rate at which the water runs on that surface.
Okay.
Okay, so
Thank.
it actually takes into account the friction loss. It'll take into account if there is an absorption coefficient embedded within that material. If it's very high reflective material, so the water won't get absorbed and things like that. So that's why it's called a runoff coefficient. It's the efficiency at which the water will drain on that particular surface.
Okay. Thank you.
Fair enough? Okay. Hi. What happened? Oh, okay. You want to come here? Yeah, I'll join. Come. Sure, I will do. Okay, guys, just wait, huh? Swati is facing some trouble, so I will just I will share the screen instead of. Uh, she has to stop sharing the screen for me to share it. Hey guys, I'm going to stop the recording and restart the recording. Okay.